and capacitance of a capacitor. Now, let's start with capacitor. What is a capacitor? A capacitor is a device used for storing of what? Electric watt charge. A capacitor is a device used for storing of what? Electric watt charge. To move further, it consists of what? Two plates, which is the what? The positive and the what? The negative what? Plate. Now, talking about this capacitor, we have types of what? Capacitor. Example of type of capacitor we have what they call the variable air what? Capacitor. We have the mica, and we have the paper what? Capacitor, etc. But coming back to what? Capacitance of the what? Capacitor based on your JAMB level. We said capacitance of a capacitor can be defined as a ratio of what? Charge per unit what? Potential difference. When you say capacitance of a capacitor is a ratio of what? Charge to potential what? Difference. But capacitance of a capacitor is denoted as C, which is the word, the symbol. Another word for denoted is what? Symbol. While your charge is denoted as what? Q, but it is measured in what? Coulomb, which is the word SI units. While your potential difference is denoted as what? V, and it is measured in what? In voltage, which is volts. But if I should change all these things back, now you said capacitance of a capacitor is what? Charge per unit what? Potential what? Difference. That means when my capacitor of capacitance, the symbol is C, I can have C equals to what? Charge per unit what? Potential what? Difference. That means my C equals to what? Q over what? V. In other way around, based on the law, if you don't understand mathematics, it's very hard for you to solve problem in physics. I can also say C equals to Q over V. This one can give me over 1. You cross multiply. Q times 1 is what? Q. Equals to C times V is what? CV. This is a formula for what? Charge. Between what? The two what? Plates. Now, let's move further. This capacitance of a capacitor can be arranged in what? In series, and it can also be arranged in what? In parallel. But capacitance in series, for me to get capacitance in series, I'll have this diagram. Sorry. Capacitance in what? In series, which this is your C1, C2, and C3. But remember, this C1 is across what? V1, while this one is across what? V2, and this one is across what? V3. But for me, to get my formula for capacitance in series, I'm going to have the total potential difference from this circuit, give me V total equals to V1 plus what? V2 plus what? V3 for my what? Total what? Potential difference from the circuit. But coming back to this, when I have Q equals to CV, let's make this V subject of the what? Formula. I can divide both sides by what? C. C cancel this C. What am I left with now? V equals to what? Q over what? C. When my V equals to what? Q over C, I can substitute this back to this. What is my V now? Q over what? C. I can have Q over what? C. Total equals to, this is V1. What is your V? Q over what? C. So definitely when you have this V as Q over C, it will be Q over what? This V1 is across what? C1. That should be Q over what? C1 plus, likewise this one will be what? Q over what? C2. Why the last one be what? Q over what? C3. When you have this, having this, you move further, say this Q over C total can give me Q times 1 over C total. Because this Q times 1 gives me what? Q over what? C what? Total. Which is equals to, student, what is common to both sides here? Q is common to both sides. Then I have Q into bracket 1 over what? C1 plus 1 over what? C2 plus 1 over what? C3. Because this Q is common to both what? Sides, bringing out the Q. From here I can equate this Q out. And I'm left with what? 1 over C total equals to what? 1 over C1 plus 1 over what? C2 plus 1 over what? C3. So this is the formula for what? Capacitance in what? In series. That is the formula for what? Capacitance in series. We also have capacitance in parallel. Capacitance in what? In parallel. For my capacitance in parallel, I will have something like this. Capacitance in parallel. Capacitance in parallel, give me this. This will be C1 again, C2, C3. Remember, capacitance in series is great. Why the one in capacitance in parallel is like this. But this one will be across what? Q1, Q2, and what? Q3. C1 is across what? Q1. C2 is across what? Q2. While C3 is across what? Q3. Now let's find our capacitance in parallel. For me to get my capacitance in parallel, I'll have total charge there. Q total will be what? Q1 plus what? Q2 plus what? Q3, which is the total charge from the wall circuit. If you now go back, remember we have Q equals to what? CV from our formula. So anywhere I say Q, I can change it back to what? CV. So this Q here change back to what? CV total equals to, this Q here will still be what? CV. But remember, Q1 is across what? C1. So this one will be what? C1 what? V. Plus this one will be what? C2 what? V. Because this Q2 is across what? C2. While Q3 will be what? C3 what? V. Now, I can have this as V times C total equals to what's going to both sides there? V. This one will be C1 plus C2 plus what? C3. When I have C1 plus C2 plus C3, remember this V can cancel this V out, student. What am I left with now? C total equals to C1 plus C2 plus what? C3. From this is your formula for capacitance in what? In parallel. Capacitance in parallel. This is capacitance in parallel, while this one here is capacitance in what? In series. Capacitance in series. This capacitance in what? Series. So whenever you're given a diagram like this to resolve on the day of your exam, when you have something like this, is what? Capacitance in what? In parallel. And which the formula is what? C1 plus what? C2 plus what? C3. Now, to move further, let's go back to the past question. We bring out some problems. Let's solve. Make use of what? Capacitance in what? In series. Also, capacitance in what? In parallel. But remember, this capacitance of a capacitor is what? Is constant. Is what? Is constant. Because it said charge is directly what? Proportional to the potential what? Difference. Charge is directly proportional. Charge is directly, this is sign for your what? Directly what? Proportional to the what? Potential what? Difference, which is PD. And you know that your symbol for charge is what? Q. Directly proportional. Potential difference is always what? V. Remember, this thing has to change to what? A constant sign. And I have Q equals to, as we use mathematics, I'll be using what? K. But here we're using what? CV. You can see that C wasn't there before. That means my C is what? Is constant. C is what? Is constant. So that C that is constant is what I call capacitance of a capacitor. It's called what? Capacitance of a what? Of a capacitor. But before we move on to solving question from the past question, let me quickly explain something to you. In practical aspects, if you have one, do F. This sign that looks like U is called what? The macro. What do I call it? Macro. Giving you, this is your one. If you want to convert it now, this macro means times 10 raised to power minus what? 6. And this F here is what? Farad. This farad is the XI unit. Farad is the XI unit for what? Capacitance of the what? Capacitor. Is the XI unit for what? Capacitance of a what? A capacitor. So when I want to pronounce it, I call it what? 1 macro what? Farad. It is called 1 macro what? Farad. So this macro, to convert it, means 10 raised to power what? Minus 6. In other way around, if you have 1 MF, this M here means what? Milli. It means what? Milli. And milli gives you 1 times 10 raised to power minus 3 what? F, which is your what? Milli. What about if we have 1 NF? 1 NF. From this N here means what? Nano. It means what? Nano. Giving me 1 times 10 raised to power minus 9 what? Farad. Nano. 1 times 10 raised to power what? Minus 9 what? Farad. If you have 1 PF, P means what? Pico. P means what? Pico, which gives you 1 times 10 raised to power what? Minus 12 what? Farad. Whenever you see something like this, you should be able to convert it back. 1 to F means what? 1 macro what? Farad. So this macro means 10 raised to power what? Minus 6. N means what? Milli, which is 1 times 10 raised to power what? Minus 3 farad. And N means what? Nano, 1 times 10 raised to power what? Minus 9 farad. While P means what? Pico, 1 times 10 raised to power what? Minus 12 what? Farad. But remember, we all know that kilo is always what? 1000. But we're talking about what? The negative based on their indices, index form. Now we cannot go back. Let's pick some questions. Let's solve. We solve this. For example, if you're given something like this to solve, or along the line, you come across something like this on the day of your exam. Question 1 says, question 1. But before I give you the question, please remember, I said CT equals to what? C1 plus what? C2 plus what? C3. I said this one is what? Capacitance. Capacitance in what? In parallel. Parallel. Why 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over C3 is what? Is capacitance in series. Remember that. But one thing I forgot to explain to you is that you see this C total here, it is called effective capacitance. It is called what? Effective capacitance. They call it what? Effective what? Capacitance. At times you see some teacher, they will use the word total capacitance. Total capacitance. If I don't want to use the word effective capacitance, if I don't want to use total capacitance, they may say calculate what is equivalent. Equivalent capacitance. Please take note. This city here means what? You'll be asked to calculate what? Effective what? Capacitance. Or you'll be asked to calculate what? Total what? Capacitance. Or you may be asked to calculate what? The equivalent what? Capacitance. Be you anyone you're asked to calculate that. So now, let's take a look at this question here. From the diagram below. From the diagram below, find the effective capacitance. From the diagram below, find the word effective what? Capacitance. So if I'm having something like this, sorry. Now we are given here 2 microfarad, 2 microfarad, 2 microfarad, and 2 microfarad. From this diagram here, this circuit here is in what? Is in parallel. Is in what? Is in parallel. This circuit here is what? Is in parallel. When this one is in parallel, remember this one is C1. This one here is what? C2. And this one here is in what? Is in C3. Remember, I told you anything in parallel gives you what? C1 plus C2 plus what? C3. That means you have to sum everything together. So to get my what? Effective capacitance there, I will have CT equals to what? C1 plus C2 plus C3 to get my what? Effective what? Capacitance. That means this my CT is the what? Effective what? Capacitance I'm looking for. I can have CT equals to what? Student, what's my C1 there, which is what? 2 microfarad plus what is my C2 again? 2 microwatt farad plus, and what is my C3 again? 2 microwatt farad. So from here, I can sum everything together. Me summing everything together, I want C total should be what? 2 plus 2 is what? 4. 4 plus 2 again is what? 6 microfarad, which is your what? The answer to the first question. When you have a diagram like this, it is resolved in what? Parallel. And parallel formula is what? C1 plus C2 plus what? Plus C3. We give you what? You sum everything together. The final answer is what? 6 microwatt farad. There will be at times, or sometimes, you may be given a question that it will consist both parallel and what? And series. Let's take a look at something like that. Parallel and series. When you're given a question like this, maybe you're given a circuit. When you have, capacitance of a capacitor. Capacitance of a capacitor. What about if you're given a circuit like this? Look at something like this. X, Y. You are given this place. Let me say 2 microfarad. And given this place 2 microfarad. This place also 2 microfarad. And given this place also 2 microfarad. The question now says, from the diagram above, find the total capacitance. Find the total what? Capacitance. You find what the total what? Capacitance. Student, look up. Remember, I told you that whenever you have something like this, is in what? Parallel. So definitely this one and this, they are both in what? They are in parallel. But this one is standing alone. This one that is standing alone is in what? Series. This one also is in what? Series. But for me to get the total what? Capacitance, I have to resolve this parallel first. If I should resolve this parallel first, it will give me what? Just a battery. For me to resolve this, fine, I can decide to make this place C1 and this place to be what? C2. Since they are in what? In parallel. For a formula for parallel, I'm going to have C total equals to C1 plus C2. You can see that it's not up to 3. But this one is 2, so you have to sum it together. That means C total equals to what? What's my C1 there? 2 microfarad. Plus what's my C2 there? 2 microfarad. When you sum this thing together, that should be what? 4 microfarad. Gives you what? 4 microfarad. When we solve these two, gives you what? 4 microfarad. You can now come back here. You can redraw your diagram. Say, remember this one was 2 microfarad, but the final answer for this, when you resolve this, gives you what? 4. You now have what? 4 microfarad. You go again with the last one here is what? Is 2 microfarad. You have your what? Your X, and you still have your what? 1. From here, this one is now my C1, C2, and what? C3. You can see that I resolved this in parallel to give me what? Series. From here now, the circuit now is now in what? In series. And the formula for series, remember I told you, gives you 1 over what? C total equals to 1 over C1 plus 1 over what? C2 plus 1 over what? C3 to get my what? My total what? Capacitance. I can substitute this now. 1 over C total, student. 1 over what is my C1 there? 2. Plus 1 over what is your C2 again? 4. Plus 1 over what is my C3 there? 2. From here, I can have 1 over C total equals to, you find the LCM of 2, 4, and 2. Let me make something clear for you, because some of you don't even understand how to find LCM. If you want to find your LCM, you have 2, 4, 2. You draw your 4 in line. The second 2 you draw. This one again, you draw. You draw your line here. What is the lowest number there that can divide it? This should be 2. 2 in 4 is what? 2. How many 2 can I see in 2? 1. How many 2 can I see in 2 again? Is what? 1. What can I use again to make all these things 1? I can use 2 again. 2 here, 1, 1, 1. So what is your number there? 2 times 2. And 2 times 2 is what? 4. So in a nutshell, the LCM of 2, 4, and 2 is what? 4. You draw your what? You divide what? Sign. You call 4 divided by 2 is what? 2. Use that 2 to multiply the numerator. 4 divided by 2, remember, is what? 2. Use the 2 to multiply the what? The numerator, giving you what? 2. Plus 4 divided by 4 again is what? 1. 1 times 1 is what? 1. Plus 4 divided by 2 again is what? 2. Multiplied by the numerator again is what? 2. From here, can I have 1 over C total equals to 2 plus 1 is what? 3. Plus 2 again is what? 5 over what? 4. You cross multiply because you're looking for what? C total. CT times 5 will be what? 5CT. Equals to 1 times 4 is what? 4. From here, I divide both sides by what? 5. 5. Cancel what? 5. What's my final answer for C total there? 4 over what? 5 macro what? 5. Which is what? The answer to the second what? Question. So I'll be back in a jiffy. Thanks so much.